Perfect. Question 4 gives you some info, and then it asks you to calculate something. Gentlemen, thank you. So when it gives you info like this one says if this and this, like it's giving you random info, you have to somehow use that information to then calculate what it's asking you to do, right? Like connect those things together. The first one is log base n of a. The second one is log base n of b. So if I could somehow take this thing and rewrite it as these things separated out, I could then calculate the values of it. Right? You have to use those things to calculate what it's asking you to calculate. This is log laws, but in reverse. If I have a times b, I can break that up into adding. So it is now log n of a plus log n of b. Then I can plug these values in. This is 3.6 plus 2.7. That is way too easy.
So how would they make that different?
That's 6.3, right? Mm-hmm. How'd they make that more difficult? The one above it is pretty similar, probably a little bit more challenging. That's probably an example of how they can make it a little bit harder. They can just add in more log laws. That's possible. Put a number in front of it, so maybe it's like 2 times log NAB. But yeah, honestly, it's not going to be much crazier though. All right. Solving logs and exponents. A student graphed the following equations: equation 1, equation 2, equation 3, equation 4. The student could estimate the solution of the equation log 5x equals x minus 3 by using the graph of the equations. Equation 1, 2, 3, or 4, we have to choose. That's a tricky one. So if you were trying to solve this thing, solution of this thing, the second one's not bad. Like it's easy to kind of tell that this is equation 3. Right here. And this one is going to be one of our other graphs. Pardon?
Can it be 2 different equations?
Yeah, using the graph of the equations. No, I think you're just going to, you're going to have equation 3 as one of them, right? And then log base 5 of x, you're going to want to mess around with too. I am not sure. I'm thinking so. Yeah, that would actually work. I got suckered into the trick answer of x minus 3 because log base 5 of x isn't going to help you at all. Like that's a hard one. So if you looked at these things, if you made those equal to each other, so if you graph both of them, that's 5x minus 3 equals x. That's what would happen when you graph those two equations, graph 2 and graph 4. You could rearrange that using logs. So this would be log base 5 of x equals x minus 3, which is what they gave us here. So you would have to graph equations 2 and 4. Tricky. Sure. Of words like permutation and combination. Actually, she probably does, so I asked her. Question number 2. Solve each of the following equations algebraically. Make like bases if you can. Write it logarithmically if the exponents is on one side. Oh, that's nice that it's giving you all these examples on how to do it. Okay, solving. So your goal is to solve for x. X is in the exponent. You have 3 different ways of tackling this question. Way number 1 is to get like bases. So if you can get like bases, that's definitely the way to go. This is a question that you can get like bases.
It's nice.
Before we do that, though, we have to deal with this. I find that's an easier thing to deal with first. That's 4 times 4 to the power of x minus 9. You need to add those exponents, right? Use your exponent laws. So this is 8 to the power of 3x plus 4 equals 4 to the power of x minus 8. Add those exponents. So 1 minus 9 is negative 8. I find it easier. You don't have to do that step first.
You want to divide the 4 over?
No. And that's what I think most people would do is they divide the 4 over, and you can't do that. Because that 4 is a coefficient. So if you divide that 4 over here, 4 can't divide into this because this has an exponent. This is a power, right? So I can't just go divide it. That's why I think it's better to combine them into one power. And now I have a power equals a power. And now I can do like bases. Like bases means you want to rewrite the base of the power as something smaller, never bigger. So for instance, 8 is 2 to the power of 3. Right? I'm rewriting it as a smaller base. The other one, I can take 4 and rewrite that as 2 squared. Always going smaller. You are never making your base larger. The reason we do this is because if the bases are the same, they already equal. So you can ignore the bases and focus on now the exponents have to equal each other. This gives me a new equation. That new equation is 3 times 3x plus 4 equals 2 times x minus 8. Notice that I'm multiplying. I put brackets there because when I have an exponent with an exponent, I multiply the exponents together. This is not just 3 times 3x. This is 3 times 3x times 4. Okay? Like it's in brackets like that. We can power through solving this thing. So get rid of the brackets, multiply the 3 in, multiply the 2 in. That's 9x plus 12 equals 2x minus 16. Move your x's left, your constants right. You have 7x equals negative 28. Divide by 7, and you get x equals negative 4. If a question said that you had to use like bases, this is what you would do. Like is a same thing as saying same bases. Question?
Nothing. I just had moved my 28 over and then just took out a factor of 7, and then you have 7x plus 4. So then you're at 2. Yeah.
Yeah, that works. Okay, that's using same base strategy. If you had a written question that says use same bases, you have to do that. Question B. X is in the exponent. So the first thing I check is, could I do this as same bases? You could do this as same bases. So 9, I know I could rewrite as 3 squared. Looking at the power on the right, it's a fraction, but there's a 3 on the bottom. So I could rewrite that as 3 to the power of negative 1. That gets rid of the fraction for you, right? It takes your denominator and moves it up to the numerator, but it gives you a negative exponent. You now have same bases. Those 3's go away. I now have 2 times 2x equals negative 1 times x plus 6. Multiply the 2 in, multiply the negative 1 in. That gives me 4x equals negative x minus 6. Move the x over. That's 5x equals negative 6. Divide by 5. X equals negative 1.2. Oh, -1 times +6, -6. This is a 6, right? Yeah, it's a 6. Again, that same base. They do love to give you that like negative exponent stuff. All right, question C. Looking at that one, I see x is in the exponent. My go-to is to get like bases or same bases. I can't get same bases on that question. 26 cannot be rewritten as 3 to the power of something. 26 can be rewritten as anything to the power of something. These not with whole numbers. So your second strategy to solving an exponent is to change into a log. When you change this into a log, you will have log, base of the power becomes the base of the log. The argument goes to the other side. The exponent drops down by itself. And I have log base 3 of 26 equals x minus 1. If I wanted to solve that, I would add 1 to both sides. So I have log base 3 of 26 plus 1 equals x. Notice that I didn't say log base 3 of 27. All right, this 26 and this 1 cannot be added together. This is part of the log, this 1 is not part of the log.
She needs so we learn.
Yep.
Do you have to solve the log?
You definitely could. So like that would be an exact solution. If you wanted to solve that in your calculator, you just go log 26 divided by log 3 and then add 1. So rounded, that'd be 3.97. One is rounded, one's exact. That is the exact solution. That's rounded to the nearest 100. All right, D. Again, we get this problem where we can't use same bases. The other problem is we can't convert that into a log. So if I tried converting this into log form, I'm going to show you what would happen and why it wouldn't work. If you went, don't write this down. So if I went log base 3, this whole thing over here would become your argument. And that exponent can't be dropped. Yeah. Yes. And you would end up with x's in the log, which isn't going to help you. Right? And that's going to get very messy. So instead, when you have this situation where you have x's in the exponent on both sides, and you can't do same base, you are going to log both sides. It becomes log base 10 of 3 to the power of 2x plus 1 equals log 1 over 5 x minus 3.
Can you explain this to us like when we first learned this? Why is that possible? What can we do?
To log base 10 both sides. I think it's because it's what you do to one side, you do to the other side. So you're rewriting both sides as log base 10, which is fine. Then we get these questions that are very like messy to solve. Because we're going to take these exponents and we're going to drop them in front. And we're going to have to expand with logs. So you have now 2x plus 1 times log of 3 equals x minus 3 log of 1 over 5. You do expand. So you're going to multiply the logs into the brackets. And you get 2x log of 3 plus 1 log of 3, which is just log of 3, equals x log of 1/5 minus 3 log of 1/5. So I log both sides, drop the exponents. When I drop the exponents, I actually do expand, and it looks terrible. But the reason we expand is so that we can now move our x's to one side and our constants to the other. This is an x term, 2x log 3. This is an x term, x log 1/5. The other two are constant terms, meaning they're just numbers. There's really weird numbers. Right? So I can move them around by subtracting or adding them. So I'm going to subtract log 3 to the other side, because that'll move it over here. And I'm going to subtract x log 1/5 to the other side. And I get 2x log 3 minus x log 1/5 equals negative 3 log 1/5 minus log 3. And I've got all my x's on the left side of the equation, all my constants on the right side of the equation. The reason I do that is so I can do a greatest common factor of x on the left side. If I take x out of the left side, I can then divide everything else over. So I GCF an x out. And I get that. And I divide the other binomial to the other side. On the left-hand side, when I divide by that entire thing, those binomials will cancel out. So x equals that massive equation on the right. You likely wouldn't have to calculate it. It would be left in that condition. It'd be left as that. If you do calculate it, what'd you get?
I got 0.98, but I might be wrong.
We'll go with that.
I guess I'm not wrong. I'm never wrong.
If it says algebraically, you have to do it that way.
So if we don't have to do algebraically, how do you do it?
If it doesn't say algebraically, y1,
Yeah, and then where they intersect.
y2, second trace intersect. So you could confirm your answer even by doing that and know, okay, the answer is going to be 0.98, and then algebraically get 0.98. That's fine too. It's a good way to check your answer. But if it says algebraic, you must do it algebraically.
If it just says solve, do we leave it in that, like the form, or do we actually calculate x?
It would tell you how to solve. It would either say exact value or decimal. It would tell you. It wouldn't just say solve. All right. Number 3. In logarithmic form, the solution of, so there's a perfect example of x is in the exponent. We want an exact value. Look at all the answers. It's logarithmic form. All right. Solving this thing. X is in the exponent. Best strategy, like bases. Can't do like bases. 50 cannot be rewritten as 5 to the power of something. Not possible. So I change this into log form. This is log base 5 of 50 equals x minus 3. I move my 3 over. I get log base 5 of 50 plus 3 equals x. The answer would be the third one. The only difference between their answer and our answer is they've done change of base, meaning the way that we put it into the calculator. So you can rewrite any log by making them both the same base, and you put the argument on the top and the base on the bottom. For the record, it does not have to be base 10. Typically, when we do like base, you do base 10 because it's easiest for our calculator to work with. But you could do whatever base you wanted as long as you make the top and the bottom the same base.
Why would you do it?
I don't know why you'd ever do anything else than 10. I don't got an answer to that. You would just make it log base 10 because then your calculator can do it. Yeah. Yeah. Unless they had told you like what log x of 50 was, then you could make them both base log x, for example. You know what I mean? But I don't know why they would do that either. Number 4. If log of 8, x plus 5 minus log of 8, x minus 2 equals 1, then the value of x is, okay, solving a question, I want x by itself. X is part of the log. That is assigned to me. Then I want to turn this into a power. I want to make this exponential form. Yep.
If it's 1, can you just change it to the log 10 of 10? Or I guess log 1 1? Like, how do you change that one?
We're not going to change it.
So how do you?
So looking at that, I want to get into exponential form. You can only do that if you have one log. We have 2 logs here. But we have log minus a log. And log minus a log is one of our log laws. We can divide those arguments. So it's now log base 8 of x plus 5 over x minus 2. And that is equal to 1. Then you can turn this into a power. The base of the log is the base of the power. Whatever was by itself is the exponent. And that equals x plus 5 over x minus 2. 8 to the power 1 is 8. If I'm solving for x, I got to get rid of that fraction. So I'm going to multiply both sides by x minus 2. And I have 8 times x minus 2 equals x plus 5. Multiply the 8 in. That's 8x minus 16 equals x plus 5. Move my x's over, move my constants over. I get 7x equals positive 21. Positive. I usually do say that. X equals 3. That's where our log laws come in, right? We talked about that when we did this unit test. We struggled mightily on when to use log laws because it doesn't say use log laws to solve this. Right? It's up to you to recognize I can use a log law there. Erica recognized. And you just got a shout out on my YouTube video. So that's like, that's a big deal. You might be famous. You owe me royalties on whatever kind of profit you make off that. Yeah. All right. Number 5. Same situation. I have log base 7 plus log base 7. I should immediately identify those are the same base, adding. That means I can combine those two logs together by multiplying those two arguments. So this becomes log base 7 of x, of 1. What am I doing? I'm like skipping steps here and I shouldn't do that. Log base 7, x plus 1 times x minus 5 equals 1. The whole purpose of getting one log is so I can then switch it out of log form. I now want it exponential form. I'm going to turn it into a power. This is 7 to the power of 1 equals x plus 1 times x minus 5. To solve that, I'm going to have to get rid of those brackets. I'm going to expand it. When you expand it, you get x squared minus 4x minus 5. I identify, hey, that's a quadratic. So I move my 7 over so that I can solve my quadratic by factoring. I move my 7 over by subtracting 7 to both sides. So it's now minus 12. Things that multiply to be negative 12 and add to be negative 4 would be x minus 6, x plus 2. Giving me two solutions, x equals 6, x equals negative 2. Both of those are algebraically correct roots. Correct. So extraneous roots are roots that algebraically worked, but when you test them, they don't work. So you should try to verify your solutions when you can. When you verify them, that means you go to the equation and you change x to actually be 6. So this would become log 7, 6 plus 1 plus log 7, 6 minus 5 equals 1. That's log 7 of 7 plus log 7 of 1 equals 1. If you have the same base and same argument, that is 1. If your argument is 1, that's 0. So 1 plus 0 equals 1. That works. Left side equals right side. 1 equals 1. If you try the other one, it does not work. Log base 7 of negative 2 plus 1 plus log base 7 of negative 2 minus 5 does not actually equal 1. The reason it doesn't is because you're going to get negative arguments. And you can't have negative arguments. Exactly. And that's like just fundamentally doesn't work when it comes to logs. Like this is not possible. Negative arguments don't work. That means that is not an answer. Remember, and we did not do this on our test. If there's two answers, you write them both. You cross out the one you don't want. This.
Because it's asking what the extraneous root is, would you
The extraneous root would be, yeah, you would write out the extraneous root is negative 2. But if you were solving this, showing that it doesn't work doesn't count as denying that answer. You have to show it doesn't work and cross it out. You have to put a cross through it. What is the extraneous root? The extraneous root is negative 2.
So I have to show, like I have to do a proof. Or I prove that it's not.
As long as you put an x through x equals negative 2, you're fine. You do not need to actually prove it unless it says verify. But you have to cross it out. All right. Log. Oh no. Oh, good. Log application questions. Question 1. The price of a particular product doubles every 35 years. If the price of a product was $16.40 on January 1st, 1996, the price of the product will be $36.50 in the year blank. And you got to figure out the year. Okay. I think it's question. I'm pretty confident it's on your. So it is on your formula sheet. It's halfway down the left side. You have this. Y equals A B to the power of T over P. Okay. Funny looking P. Yeah, breaking down like what these things mean. So Y typically is like an end value after a certain amount of time. T is your time. P is how long it takes for your rate to actually be effective, right? It's technically like your period, but it's how long for the rate. So for example, this question says it doubles, there's my rate, every 35 years. There's my p-value. Because it would take 35 years for the rate to actually happen. Your A value is your starting value. Your B value is 1 plus or minus your rate. Now, if they give you a rate, then you just put it into that little formula 1 plus the rate. So there's like, oh, it goes up 10%. You'd go 1 plus 0.1. This one said that it doubles, which throws people for a loop. Doubles means 100% growth. Right? If I have $5 and I have 100% growth, my money doubles to $10. Right? So this is 1 plus 1. Right? Because the rate is 100%. That's doubles. Or when you go to put these things in, doubles just means that your B value is going to be 2. If I said triples, the B value is going to be 3. Quadruples, B value is going to be 4, so on and so forth. Instead of trying to think of it as a percentage, it might just be nice to be like, oh, doubles means B equals 2. My equation is Y equals the starting value was 1640 times B, which is doubling, to the power of time, which we don't know, divided by 35. We do, yeah. But like we just built our equation. So like this is just me building an equation. When I build an equation, I don't put values in for X and Y. I'm just putting values in for A, B, and P. You'll then be given Y or X and solve for the other one. In this case, they said the product will be $36.50. That's an ending value. You're trying to find in the year. So you're trying to find X. This is $36.50 equals $16.40, 2 to the power of X divided by 35. You need to solve for that value of X. To solve for that value of X, because it's in the exponent, you'll have to change this into a log. That means I need to divide 16.4 to the other side. I cannot change this into a log unless the power is by itself. That power is not by itself. If that's an irrational decimal, which it might be,
Yeah, it's 62.22.
it is,
Yeah.
then we are going to leave it as a fraction.
365 over 164.
Is that, yeah, I think that's the best fraction you get too, isn't it?
Because you just take out the decimals.
Or you could just leave the decimals. As long as you leave it as a fraction or use all the decimals. Like kind of up to you. You could leave it just like that if you want. So I have 36.5 over 16.4 equals 2 to the power of x divided by 35. Then I can change that into a log. Multiply the 35 over. Throw that in your calculator. You get 40.8 equals x.
I got 40.4. Wait. 40.3970.
Oh, I thought this was an 8 because my pencil carried over. That's a 5.
No, you get around year 41. So no, like 41 years on top of 1990. Oh, right.
So that means that it's been 40 years since 1996, right? That's the number of years. If you want to figure out what year you're in, you'd go 1996 plus 40.4. And you get the year 2036.8. Oh, sorry, point 4. I'm still pointing at my calculator.
So when you leave it as 2036 because it says it was in the year?
Good question. So,
That's where I
Well, no, because if it's in the year.
Because it's like-
point
It's
four.
point four through that year. So it's,
I think he's gonna explain. Yeah.
weird. So, because they started on January 1st, right? That means the start of the year. So when I went 40.4 years in the future, if I did 40 years, that would be January 1st, 2036. Now you're 0.4 of the way through that year, but you are not completed the year 2036. So when it says what year does it happen? It happens in 2036. It just happens 0.4 of the way through the year, which would be like,
It's still in that year.
yeah, it's still in the year 2036. It would just now be like April, right? Instead of January 1st. But it's still in the year 2036.
So if that month was different, then you would have to. Like what if it was
So had it said like, yeah,
December? Then?
it's always going to be the start of the year.
Okay.
Yeah, they're not going to make you think hard like that. But the 0.4 means like it's 0.4 of the year after January 1st.
And would you still, like if it was like 0.7?
Yeah, you wouldn't round it down, up or down. Like you're in the year 2036. So if it was 2036.9, I'm still in the year 2036. It's just like December, right? It's almost over, but I'm still in 2036. Always round it up before, yeah, to get like enough, right? That's true. Now I'm saying round down. Just don't remember anything anyone ever taught you before this.
Why is the P45 not like the time?
You know how I actually remember it?
Because I always confuse them.
Yeah, that's fair. So here's how I remember it. If I wanted this to double, like, and that's what this rate's saying is doubling, right? This needs to be 2 to the power 1. So that means this would have to be 35 years because that's when it doubles. And 35 divided by 35 would become 1. If I was less than 35 years, I haven't doubled yet. So I would have a fraction that's smaller than 1. So like 2 to the power of, let's say it's in 5 years, 5 over 35 would be a decimal. And I'm not quite doubling yet. Anything over 35 years, I should be doubling. So it'd be like 36 over 35 should be more than double. So the decimal is greater than 1. That did not help at all.
Like saying, I get what you're saying. I just don't think that helped me with like which one's which.
Yeah, that's fair.
Just gotta know.
The top one is time that's passed. The bottom one will always be how long it takes for your rate to apply. And it'll always be that way.
So because this is saying after 35 years.
It doubles every 35 years. So it takes 35 years for this rate to work. So this is the number that goes in the bottom. The bottom number is however long it takes to actually work for that rate to happen. It is weird.
I always confuse.
You're not alone. Yeah, like everyone in the room's like, yep.
Because like that should be like the time that passed is 35 years. Or is that just like
No.
between the two points?
Like when I read that first sentence,
I mean,
it's like the price of a particular product doubles every 35 years. I don't know how long it's been yet. They're just telling me about the rate.
So if it's saying double, triple, or whatever, you're just finding t because and t should be bigger than whatever.
well, it's asking. how
Typically,
long it
yeah.
is. Which kind of is illogical.
Logically illogical. Illogically illogical. One or the other. It is tricky. Like knowing how that fraction works is a mess. Okay, let's try number 2. Hey, look, it's marked standard of excellence. So there you go. The growth of bacteria can be written as NT equals N naught 2 to the power of T divided by 40, where NT is the final number of bacteria, and O is the initial amount of bacteria, and T is time in minutes. The logarithmic expression for time it takes for the number of bacteria to increase from 50,000 to 700,000 is. Okie dokie. Before we actually get into this, if we look at the equation,
What does the n subscript O mean?
N naught usually means like an initial value. You see it in physics for like 0 time has passed. It's like you're starting. Looking at this, that's an exponential equation. Let's just break down what it's saying to us because it's actually saying a lot. This is my n value. This is my a, so that's my starting value. I don't know. This is my rate. It's doubling. This is 2. The exponent is t over 40. That means it doubles every 40 something. In this question, it's minutes. That's what this is telling me. It will double every 40 minutes. The t is how much time has passed. So if I said, okay, what's the population after 5 minutes? I would put 5 into here. If it had been 40 minutes, I'd put 40 into here, and then I know it doubled because 40 divided by 40 is 1, so it's just 2 to the power. But like when you look at an exponential question and a word problem, it tells you a lot. You should be able to look at those numbers and realize what the numbers mean in context of the question. Okay, they asked us. We're looking for a log expression for t. I'm trying to figure out what t equals. And I want it written as a log. The only way I can do that is if they somehow gave me all the other variables. In this case, that's n of t and n of naught, or n naught. They did do that. They gave me it increases from 50,000. That's going to be my n naught. To 700,000. That's going to be my n of t. Started at 50,000, ending at 700,000. My equation is 700,000 equals 50,000. 2 to the power of t over 40. Yep.
So like this question doesn't want a decimal answer, but like if it does, can you just go 1, 1 by 2?
Yep. 100%.
That's what we could have done for the last one. We picked
100% could have done that. This stage, this is y1, graph it. This is y2, graph it. Find where they intersect. And I'm gonna get the answer.
So this stage you graph like 700,000.
Yeah, this one I would graph 700,000 in y1, graph 50,000, 2 to the power x divided by 40 into y2. Second trace intersect, and it would tell you where. The problem is that it wants it as a log, so you're going to have to do it algebraically.
Why is this the same?
Because it's going to be a word problem, so we have an exponential function where you have to understand what an exponential function does, and then converting into a log. So it's mixing two ideas of logs and exponents. And I think we're also going to have to do change of base, is my guess. I can't turn that into a log right now because of the 50,000. So I divide that 50,000 to the other side. That should be a pretty nice number. 14? So I have that now. I can turn that into a log. It's log base 2 of 14 equals t divided by 40. Multiply 40 to the other side. Log as time as an expression of logs is 40 times log base 2 of 14. If I look, oh, that is an answer. Good. Let's see.
It seemed too easy to be standard equations.
That's what happened with the number 5 as well.
Not terrible.
It seemed really easy, so.
Yeah, it's not bad.
That's good.
Funny, I'm making up this test and I'll be like, I don't know what yeah. Good. Really.
Number 3. The population of a particular town on July 1st is 20,000. If the population decreases at an average annual rate of 1.4, how long will it take for the population to reach 15,000? Set up your equation first, then try to solve whatever it's asking you. Okay, so setting up our equation will look like this. A, B to the power t divided by p. We want to replace A, B, and P if possible. A is your starting value. I start at 20,000. B is 1 plus or minus your rate. In this case, I'm decreasing by 1.4%. That means my rate will be 1 minus 0.014. It's decreasing at an average annual rate. That means every 1 year. That's your p-value. So it's t divided by 1. You don't even have to put the divide by 1 if you don't want to. But if you're wondering where that p went, it is just 1. Build the equation first. You've seen that on written response questions where it says make an equation. That's the first part. Then the second part is then solve for something. Okay, that's me building an equation. I have two unknowns, y and x, in this case, y and t. Then answer the question. It says, how long? That means I'm looking for t. Will it take for the population to get to 15,000? That means y equals 15,000. My equation is 15,000 equals 20,000. 0.986 to the power of x or t. T divided by 1 is just t. I got to switch that into a log because I'm solving for an exponent, so I divide the 20,000 to the other side. That gives you 0.75 equals 0.986 to the power of t. Convert that into a log. That's log base 0.986, 0.75 equals t. You throw that in your calculator. log 0.75 divided by log 0.986 is 20.4 equals t. That means it takes 20.4 years. It said how long? The answer would be 20.4 years.
So if that one, if they wanted an exact year, would you round up?
If they said in what year, that would be the year. Yeah, see how it says July 1st? That's why I wouldn't ask you in what year. Because then you're going to get into that messy situation of has it turned over into 2020, whatever.
30, you mean?
Like 0.4 of a years is not 6 months. July 1st, you're 6 months away, right? July,
But if they wanted,
August,
like,
September,
if they
October, November,
wanted-
December.
If they asked the
So-
same question, how long will it take the population to reach 15,000? If they wanted a no decimal, then would you round it still? Round up 21?
You just round normally. So it's 20.4 years. If they said round to the nearest year, it'd be 20 years.
That's fine.
Because they're asking how long, not what year.
I just didn't know because like at 20 years it won't be at 15,000, but by 21 years it will be.
Agreed, which is why they're asking to round. I know what you're saying. They would probably ask for nearest 10th.
Okay.
So it'd be 20.4. It'd be too easy. It'd be too easy to guess 20. What's that?
Could it be like a trick question? Because it's like it's 20, but it's 20.
They do a very good job of not trying to make it trick questions. Like that used to be a thing that happened, whereas like they try to trick you up on stupid things like that, like what you're talking about. They've pretty much eliminated all those style questions. So it should never be like tricky stuff like that. It should be pretty straight up. Number 4, an investment earns an interest rate of 4% compounded quarterly. How long in years will it take for the investment to double? Okay, so let's build our equation. Y equals A B to the power of T over P. And this one's a little bit interesting when we do our investments. Yeah, and our compounding messes things up. Compounded quarterly. That means they're going to charge you the interest rate every quarter. It's every 3 months in our time. That's like something that actually does happen, right? You'll get things that compound monthly, quarterly, weekly, whatever. That's how often they're charging you interest. So they're going to charge you your interest every 3 months, but they don't charge the full 4%. They break that 4% up. So your rate is not 4%. It's 0.04 divided by 4 because it's quarterly. So your new rate is 0.01. That seems too convenient. Yeah, it is. So you have to find your new rate when they're compounding quarterly. Building this thing. I don't know what y is. My starting value, they don't actually tell me either, so I'm going to leave it as a. My b value is 1 plus 0.01. My t is still t. My p is not 4. It's 1 over 4 because it's quarterly.
So then would that just be 14?
Which turns it into 4t. So we're going to go through and simplify this a little bit. That means my equation is y equals a 1.01. Yeah.
You know how like the 4% isn't that actually just happening quarterly? Like how come we had to divide it again? Because the 4% isn't yearly; it's 4% quarterly.
No, they're charging you at a rate of 4% compounded quarterly. So it was 4% and then it got compounded to become quarterly. If it said 4% quarterly, then I think you're right. You would leave it as 4%.
Why do they be stupid like that?
It would actually probably say, in all honesty, 4% and then it would go per A, which means per year.
Per year compounded quarterly. That
Yeah.
would make more sense.
Yeah, and so that's actually how you would see that rate written. It would go /A to make it clear that it's your annual rate.
I would not have divided it.
That's fair. That's fair. T divided by 1 divided by 4 is 4t. If you're dividing by a fraction, right, kiss and flip, it goes to the top. That's why it's 4t. Cool. Solving this. It asks you, how long? That means I'm looking for t. Will it take for the investment to double? So they didn't give you a starting value and they didn't give you an ending value. But what they told you was they want your end value to be double your starting value. So they told you that this is 2a. You're doubling your starting value. So my equation is 2a equals a 1.01 to the power of 4t. Divide a to the other side, and you get 2 equals 1.01 to the power of 4t. Anytime you have an investment or something doubles, it's always going to work out that way, that you get that rate on the other side. Yep.
Okay, wait, so in theory, you could have just put any value in for A and Y.
Yep.
Y was double the
100%.
I was just gonna do 2.
So if you could have put, yeah, literally it's the same thing. So you could have said, okay, what if it was 5,000? Then it would double to 10,000. And when you divide 10,000 by 5,000, you get 2. So it'll always work out that way. Solving this becomes log base 1.01 of 2 equals 4t. Divide that 4 to the other side. Divided by 4 equals t. That's not 101, it's 1.01. You get 17.4 years.
And is that in years now, or is that when we call it?
That is in years. Yes. It never asks you what the investment was. But it would take 17.4 years for my investment to double.
I didn't know that was like 17.4 of the month.
Yeah, I see what you're saying.